Hi, in this video we're going to derive the quadratic formula. Quadratic formula solves any quadratic equation. Now let's fence off the right hand side of the screen for rough working. So what we have here is a quadratic equation. I mean, we could have, for instance, 2x squared minus 3x plus 4 equals 0. To solve this, you'd use the quadratic formula. But how on earth do we get the quadratic formula? Let's see if we can solve this one rather than one particular one. So, whereas in this one a is 2, b is minus 3, and c is 4, in this one we're not saying what these values are. So my first move is to divide both sides of this equation by the number a. Now there is a danger that a might be equal to 0, and you are not allowed to divide by 0. So the first commandment of mathematics, thou shalt not divide by 0. So what if a was 0? Then this term would completely disappear and would have an equation bx plus c equals 0. In which case, take c from both sides, divide both sides by b, provided b is not 0, and would get us. So anyway, whatever goes on, this is not a quadratic equation. The highest power of x is 1, and for a quadratic equation you need a highest power of x being 2. So a cannot be 0, otherwise we've no job to do. It's not a quadratic equation. So let's just put that in here. It's understood that a is not equal to 0, otherwise no quadratic. So let's divide the left hand side and the right hand side by a, and they'll still be equal. So ax squared divided by a, we divide top and bottom of that fraction by a, the common factor a that's there, would disappear, would be left with x squared over 1, which is just x squared. So we're dividing by a to get rid, in effect, of this value here, so that we've got a 1 x squared, which makes life a lot easier. This one we would have bx divided by a plus c divided by a. When you divide 0 by a number, you still get 0. So there's the first move. Now let's proceed by moving this constant, it doesn't involve x's, this constant to this side, so we subtract c over a from both sides. So that disappears. 0 minus c over a. Now, next term, this is the tricky part. What I'm going to attempt to do is in here to get an expression that's identical to the two expressions that are equal. The contents of this bracket and the contents of this bracket are going to be equal. And there's going to be two terms in each. In other words, I'm trying to factorize this one. I'll not be successful, but I'll try. So remember procedure in multiplying out terms like this. When there's two expressions in each bracket, we do firsts, we do outsides, insides, and then we do lasts. So the firsts, this times this, has to be x squared. There's no choice for this one. We now look at the inside 2 and the outside 2. Now let's take an example. For instance, x plus 2 times x plus 2, where we have an x squared, and the outside 2 give us 2x, the inside 2 give us another 2x, so we would get 4x. And you'll notice that each of these is a half of the result, because we're adding the outside 2 are the same as the inside 2 when we multiply them. Here we get 2x and another 2x. These are identical. So whatever we get, and this is the term that involves x, so whatever we get, which is a b over a x, up here, the outsides and the insides must involve a half of this. It must be b over 2a x and b over 2a x as a half of this. I mean, when we add b over 2ax plus another b over 2ax, we will get b plus another b, lots of that x, which is 2b over 2ax, and the 2's will cancel and you'll get b over ax. Anyway, this term is a half. This term and this term are a half of this. Another way of looking at it is a half of b over ax, b over 2a. So in here we must have a b over 2a and a b over 2a. And we add them both. B over 2ax plus another b over 2ax gives you b over a, lots of x. Now, unfortunately, the last terms, this times this, and if we work out b times b over 2a times b over 2a, we get b squared over 2 times 2 is 4, a times a is 4a squared. We get b squared over 4a squared. That's not there. There is no term b squared over 4a squared. So by writing this expression as the product of these two, I've introduced a b squared over 4a squared that wasn't on this left-hand side. So let me add it to the right-hand side. And if we think about that, on the left-hand side there's an extra b squared over 4a squared. Well, there it is on the right-hand side. So everything's still balanced. We can check backwards. Let's multiply out these two brackets and see what we get. The firsts give us x squared, which is okay. The outsides give us a half of b over ax. The insides give us another half of b over ax, which makes a whole b over ax, which is that term. And then the last give us b squared over 4a squared, which isn't there. But it's appeared on the other side to balance that. So this line is the same as this line. Now, since I did this specifically to get these two brackets identical, then let's just emphasize that by writing this line as that bracket times itself, that bracket squared. This right-hand side, since I'm subtracting two fractions, let's get the denominators identical. That would involve, remember, 4a squared. I'm running out of space here. 4a squared is 4 times a times a. And if we look at this factor here, there's just one factor a. We have to introduce a factor 4 and another factor of a. So I have to multiply this fraction, top and bottom, by another 4a. So we'll come back to that. So the left-hand side is now a perfect square. The right-hand side, I'm still in the business of trying to simplify it. We've now got 4ac on the top and 4a squared on the bottom. Both fractions have the same denominator, so I can ask the question, how many of these 4a squareds have I got? It's similar to writing what 3/5 minus 2/5. You say, how many fifths have I got? 3 of them minus 2 of them. So I would have 1/5. So how many of these do I have? I've got b squared minus 4ac of them. B squared minus 4ac. Now this is interesting because on the left hand side I have something squared, and on the right hand side I've got a number in effect. When you normally have something like that, say for instance x squared equals 9, you can then proceed to say, well, x must be plus or minus 3. Remember, the negative is also, when you square negative 3, negative 3 times negative 3 does give you positive 9. So it's plus or minus the square root of 9, 3. So in this case, take the square root of both sides, but allowing the possibility that we have a negative value. So that's what I've reached. Now, left hand side, x plus b over 2a plus or minus. Now, square root of a fraction. Square root of 9/16, for instance, is 3/4. Why? Because 3/4 times 3/4 will give you 9/16. So you are allowed to take the square root of the top line and the square root of the bottom line. And let's do that here. Square root of the top line, that's the square root of b squared minus 4ac. And the square root of the bottom line, what's the square root of 4a squared? Well, 2a times 2a gives you 4a squared, so the square root of 4a squared will be 2a. Well, let's keep going. Remember, trying to solve this general quadratic equation means we need to find the value of x in terms of the a, b and c that we supposedly know. 2, minus 3, 4. These are numbers we know. These are constants. So we have to find x, get x on its own. This case we'll subtract b over 2a from both sides. So we subtract it from the left hand side, that disappears. Subtract it from the right side, and let's put that at the front. Subtracting b over 2a, and then adding or subtracting the fraction b squared minus 4ac all over 2a. And you'll notice now that both of these fractions have the same denominator, so we can say how many of these do we have. We've got minus b of them plus or minus the square root of b squared minus 4ac. And I suppose we've done. That is the quadratic formula. There are two values for x possible when we solve this general quadratic equation. One of them is minus b plus whatever the square root of b squared minus 4ac is, and the whole thing divided by 2a. And the other one is x equals minus b minus whatever the square root of b squared minus 4ac is, and that whole thing divided by 2a. So there's your two solutions to this quadratic equation. And reserved for another video will be the explanations of why this sometimes doesn't give you two solutions, why sometimes this just gives you one solution, and occasionally it doesn't give you any real solutions at all. But there you go, the derivation of the quadratic formula. A fun piece of algebra.